This alkaline hydrolysis rhesometer at the University of California is the latest in crematory technology. The high-pressure chamber, pictured above, is more environmentally friendly than your average cremation, with potassium hydroxide being mixed with water and heated to 150 degrees Celsius, dissolving the body and avoiding CO2 emissions. This is the future of death. For Wired photographer Spencer Lowell, getting a closer look at the rhesometer for our September issue feature meant diving straight in. To get the perfect shot, I was wrapped in bioplastic, just as a corpse would be, and went inside the machine. I even let my foot hang out for a little added drama, he explains. The world's most powerful artificial sunlight, a 3-story, 350 kilowatts array of 149 conical reflectors enclosing xenon short-arc lamps, can generate light 10,000 times that of the solar radiation at the Earth's surface. The €3.5 million £3 million German Aerospace Centre project, which is housed in a protective radiation chamber in Jülich, will explore the production of renewable fuel by extracting hydrogen from water vapor. Making electricity renewable has already been done, explains research director Bernard Hofschmann. But in the future there will be many applications for fuels that cannot be replaced with batteries. High-tech wildfire destroyers. This scarlet splashes fire retardant, a blend of water, wire gum and a salt called ammonium polyphosphate. Washington State aerial firefighting company Nano Flight uses the colorful cargo to prevent wildfires from destroying forests. It clings to vegetation around the edge of a fire, so when the trees burn, they produce water instead of flammable gases to help stall the progression of the blaze. Mike Lin, Aeroflight's head of flight operations, says the red color obtained by adding iron oxide makes it clear to pilots which areas have already been covered. It shows up against the green canopy of the trees. The liquid seen above being dropped on a Californian forest in 2014 is harmless for terrestrial life, unless ingested, although it is toxic to fish. This tiny 32-bit Motorola 68030, with 273,000 transistors each with data caches of 256 bytes, was captured by Miami-based photographer Christoph Morlinghaus for his Computer World series. It's possible to cram so much information and components onto such a small object, says Morlinghaus. It's like an aerial view of a city. To expose the workings of the 1 square centimeter chip, Morlinghaus opened the microprocessor by melting the welding material before placing it 2.5 centimeters away from his camera. Each transistor shown here as the densely packed blocks that make up the roofs of the cityscape is only 1 millimeter in diameter, so getting them in focus wasn't easy. Nobody has taken photographs of something so small on 8x10 film before, he says. Credit Christoph Morlinghaus. This ominous red substance is molten lava from the Pu'u vent on the Kilauea volcano in Hawaii, exposed by a skylight in the roof of a developing lava tube. This one reveals an active lava stream that is traveling to the upper right. Skylights are extremely dangerous to approach from the ground, says Christina Neal, scientist in charge at the United States Geological Survey's USGS Hawaiian Volcano Observatory. Kilauea is considered one of the world's most active volcanoes and has been erupting nearly continuously since January 1983. Credit United States Geological Survey's Hawaiian Volcano Observatory. This green gunk is alive and dangerous. In July 2016, Utah Lake was struck by an algal bloom, affecting more than 384 square kilometers of fresh surface water. The cyanobacteria releases toxins such as microcystin, which can cause vomiting, diarrhea, skin rashes, and even liver damage. Utah Lake was closed for 13 days, with a period of caution for swimmers after that. Anna Michalak, a researcher at Stanford's Department of Global Ecology, said what's going on is an interplay between what we're doing on the land locally and what's happening with the climate globally. Changing weather patterns are compounding the impact of the extra phosphorus reaching the water. It's the perfect storm. Credit Rick Ignap. TerraPattern. New York Sea of shipping containers. The search engine TerraPattern finds satellite imagery to uncover otherwise invisible urban patterns. Its deep convolutional neural network is trained using hundreds of thousands of satellite images from collaborative mapping wiki OpenStreetMap. We try to indicate what the world might be like in a few years, says Golan Levin, who created the system with his team of artists and coders at Carnegie Mellon University. Creditor a pattern still life of a frozen stem cell. This isn't an alien's eyeball, but a 15-micron wide stem cell taken from human hip bone marrow. Sylvia A. Ferreira, Christina Loppo and Eileen Gentleman, a STEM biology research team at King's College London, produced this photograph using cryogenic scanning electron microscopy. We put the cells in hydrogel and then tried to modulate the properties of this material to mimic the natural environment of the cell, says Gentleman, 37. The sample contained 500,000 cells packed into a 5 square millimeters cube. It was frozen at around 150 degrees Celsius, the point at which cryogenics begins, then broken in half, so that cells could be observed on the broken surface. It's the only method that allows us to see both the cell and its environment, says Gentleman. Credit King's College London. Pakistan's surging glaciers. This satellite image shows the flow of the Baltoro Glacier in the Karakoram mountain range in Pakistan. Snow is shown as cyan, ice is pale blue, the bare terrain is a muddy brown. The branching formation in the center of each image is the glacier's ice-tung brown with rocky debris. The snapshots come from NASA's Landsat satellite, which produces full-color images by measuring wavelengths of light invisible to the human eye. For glacier analysts this is extremely useful, says Frank Paul, senior researcher at the University of Zurich, who put together the images. These composites show clouds in a different color to snow. Unlike other glaciers around the world, these are not receding, a phenomenon known as the Karakoram Anomaly. To observe this, Paul turned Landsat images from 1990 to 2013 into an animated GIF, which reveals some glaciers retreating over short periods, others stationary, and some surging. This confirms the anomaly in climatic terms, says Paul. As for the surging, we have no clue why they are doing it. Mexico's Butterfly Highway. Each autumn, millions of monarch butterflies fly up to 3,200 kilometers from North America to gather in a tiny patch of forest in Michoacán, Mexico. But the numbers are falling fast. To combat this, in May 2015, the White House announced the creation of a 2,400 kilometers monarch migration highway that will follow the route of Interstate 35 from the top of Minnesota to the bottom of Texas. Fighting sandstorms with trees in Kuwait. This is Kuwait City as another sandstorm rolls in from Iraq. Hundreds of meters high, they travel across from the Arabian desert at speeds of up to 100 kilometers per hour, costing the region's economies dearly. They have increased remarkably, says Essa Ramadan, senior meteorologist at the Kuwait Meteorological Department. The reasons: dam building in Turkey, climate change and the environmental destruction in the wake of the Gulf War. But Kuwait is fighting back. The volunteer organization Kuwait Oasis is working to plant 315,000 trees along the country's borders by 2019 to hold back the moving sands. California's latest water preservation strategy. California's latest water preservation strategy: 96 million small black plastic balls, the last of which were dropped into the Los Angeles Reservoir in August. Left unchecked, sunlight can promote algae growth in the water, explains Richard Harrisick, director of water operations at the Los Angeles Department of Water and Power. When this mixes with the chlorine disinfectant we use, it causes the formation of carcinogenic byproducts. By covering the surface to prevent sunlight reaching the water, the balls not only halt algae growth, they also stop evaporative loss of up to 1.1 billion liters of water a year. The 10 cm wide plastic balls cost just 36 cents 23p each, with a total cost of $34.5 million, a saving of more than $250 million. The tracks left by ancient rivers. This multicolored laser images the Tambopata River in Peru. The winding black line represents the waterway. Now the surrounding squiggles are historical tracks left by ancient rivers, some 5,000 years old. The snapshot comes from the Carnegie Airborne Observatory (CAO), an aeroplane with infrared lasers. Developed by Earth scientists from Stanford University and the Carnegie Institute, the lasers create geological scans in 3D. The system highlights changes in ground elevation. Blues show low points just above the river, pinks and reds represent land a few meters higher and so reveal the river's historical roots. I can fire 2 lasers out of the plane at different angles, for maximum penetration of the forest canopy, says Greg Asnat, CAO's principal investigator. C-Wired 312. The lasers travel downwards in a series of pulses 500,000 per second, striking leaves, branches and soil. The reflections build a 3D picture of the landscape which researchers can peel back in layers. Volcanic lightning from Calbuco. This dramatic flash is a lightning storm raging at the top of a volcano. The light show, observed at the peak of the Calbuco volcano in Chile in April 2015, is a phenomenon known as volcanic lightning. In a recent geology paper, co-author Steve McNutt, a volcanologist at the University of South Florida, explained that this happens when particles of ash and lava shoot out of the crater and rub together, generating bursts of static electricity. Inside the flash, the temperature can reach up to 30,000 degrees Celsius, and it can melt ash and rock particles, McNutt says. Volcanic lightning has only recently started to be researched. Although it is independent of other weather conditions, there are similarities to thunderstorms, particularly when the volcanic plume is higher than 7 kilometers and ice starts to form inside it. This is referred to as a dirty thunderstorm, McNutt says. His research also found that volcanic lightning can leave behind a trail of glassy spheres measuring about 50 microns in diameter. Scientists can use them as an evolutionary chemical signature, which could help to better understand previous volcanic activity. Get ready to flashback. UNESCO site Shark Bay makes purest salt in the world. This is not a watercolor. It's the 7,000-hectare Shark Bay salt field in Useless Loop in Western Australia. What looked like brushstrokes are the marks left by salt harvesting machines, which produce about 1.6 million tons of the purest grade salt in the world every year. The salt is extracted from very pure crystalline seawater, 50% more saline than the ocean, says Graham Landgren, general manager of the plant, which is owned by Japanese corporation Mitsui Group. Salt water is pulled into closed lagoons by wind, gravity, a few pumps and the tide. Then evaporation and wind gradually concentrate it. After it is pumped into shallow crystallizing ponds, further evaporation leaves a thick layer of very pure salt. When 20 centimeters to 40 centimeters of it remains, it's harvested and accounts for 93% of Australia's salt production. Salt from Useless Loop is among the highest natural-grade marine salt found anywhere in the world, says Landgren. And the area is just as exclusive. Though surrounded by Shark Bay, a UNESCO heritage site, no tourists are allowed. Instead, only the salt field's employees and the families live in the area. We have our own private town, says Landgren. Salt still shaking things up. This camera explores 100 square kilometers of Mars at a time. Last year, NASA's Opportunity rover set the off-world driving record at 40.25 kilometers after 10 years on Mars. The HiRISE high-resolution imaging science experiment camera that took this picture of the planet's Proctor crater, however, is exploring it 100 square kilometers at a time. We see the whole planet, says Alfred McEwen, the University of Arizona professor who heads the research project. The rovers just see one small area. All the distance Opportunity has traveled would fit in one HiRISE image. Armed with the largest reflecting telescope to be sent on a deep space mission, the camera takes 11 photos a day at 30 centimeters per pixel resolution. And it may have found water. Pictures have shown recurring slope linear, deep markings on the planet's surface. It's difficult to come up with another explanation for these features, says McEwen. Water is the best candidate. These psychedelic patterns were created by Brooklyn Canal pollutants. These psychedelic patterns aren't art. They were produced by pollutants on the surface of the fetid Gowanus Canal in Brooklyn, New York. The body of water, one of the most polluted in the U.S., is getting a $506 million, 344 million pounds detox after being used as an industrial dumping ground for more than a century. The mud is up to 3 meters deep and has the consistency of thick mayonnaise, says Walter Mugden, Superfund Division Director at the U.S. Environmental Protection Agency (EPA), which is overseeing the cleanup. This year, a test clean will start in part of the canal, a precursor to the full operation that begins in 2017. Local sewers will be upgraded so that waste no longer overflows when it rains. A dredging operation will lift 460,000 cubic meters of sludge, and the most contaminated parts of the canal base will be capped with soil, sand and rocks to stop the water mixing with toxic sediment. The cost of the upgrade will be divided between the companies that historically polluted the canal over the years. People believe for the first time in a century that it will actually get cleaned up, says Mugden. Up close with a fruit fly's nervous system. This is a microscopic chunk of a fruit fly's nervous system. The yellow line is the equivalent of its spinal cord, says Albert Cardona, group leader at the Howard Hughes Medical Institute in Virginia. His team is mapping the whole thing in cellular detail. Cardona hopes to find insights for more efficient design of artificial neural networks and for understanding human information processing. Many lessons from the peripheral nervous system and the spinal cord will apply directly, he says. As you progress to higher-order areas, you can compare how ensembles of neurons work. Harmful superblooms on the rise in world's oceans. What looks like paint spreading through water is actually an algal bloom, made up of tiny blue-green phytoplankton, swelling by the Pribilof Islands in the Bering Sea, off Alaska's coast. Small blooms can sustain ocean life, but if they're toxic or out of control, they can have a negative impact. The big problem: a global rise in harmful superblooms. In 2013, toxic red algae blooms killed more than 200 of Florida's endangered manatees. Another bloom in early 2014 contributed to a record number of seals and sea lions being taken into rehabilitation centers in California. We've seen more toxic outbreaks, and we're concerned climate change is involved, says David E. Caron, a biological oceanographer based at the University of Southern California. These poisonous blooms create dead zones in places such as the Gulf of Mexico, Lake Erie, and can be traced back directly to humans. Agricultural runoff, pollution and sewage flush the ocean with nutrients that artificially breed algae. There's a brand new man-made wonder in China, but this time it consists of trees. More than 100 billion of them are due to be planted by 2050, across an area equal to 42% of the country's land mass, as part of the Green Great Wall Forestation Program. The aim to fend off the encroaching sands of the Gobi Desert, which engulf 3,600 square kilometers of grassland every year and smother Beijing in dust storms. According to research by the Chinese Academy of Sciences, it's already working. Our results show that it greatly improved the vegetation index and effectively reduced dust storm intensity in northern China, wrote Mingyong Tan, associate professor of geographical science at the Academy, in a December paper. Since its inception in 1978 as the 3 North Shelter Belt Forest Program, the project has met controversy over its potential long-term disruption to the ecosystem. But with 10 million km2 affected by desertification globally, and a similar project planned for the Sahara, we see a leafy trend rising. This 70-meter-deep crater suddenly appeared last summer on the Yamal Peninsula in Siberia. In November, explorers descended inside to try to understand its origins. Marina Liebman, chief scientist at the Earth Cryosphere Institute of the Siberian branch of the Russian Academy of Sciences, believes that the crater was produced by a buildup of gases in the permafrost that eventually pushed their way out. There is gas enclosed in permafrost, locked inside, says Liebman. So I think it was somehow released by warming. Dmitry Streletsky, an executive committee member for the Global Terrestrial Network of Permafrost, suspects that craters like this formed during the Holocene climatic optimum, the warm period 7,000 years ago. It's likely we will see more of these, he says. Liebman blames this destabilization on local warming, rather than climate change. For scientists, it is more important to look at something local, specifically the warm summer of 2012, she says. Global warming is for the politicians. Sydney's vertical sun trap. Despite standing 33 stories tall, Sydney's One Central Park barely casts a shadow. On the roof of the block's lower tower are 40 heliostats, motorized mirrors that track the sun's movement and redirect its light up to a reflective frame cantilevered from the taller tower. These 320 fixed mirrors then reflect the light in all directions, explains the project architect for the East Tower, Mark Giles of Sydney-based PTW Architects, who collaborated with Frenchman Jean Nouvel. Half of it comes down to the park south of the building, providing sunlight to an area that would have been in shadow. The other half is directed through an atrium to the building below. The second reflection serves an important purpose in de-intensifying the sun's rays. The double bounce of light, for the heliostat to the reflective frame, gives the effect of dappled sunlight, as though it were filtered through a tree canopy, explains Giles. One Central Park is further camouflaged by a living skin of 180,000 plants that comprise the world's tallest vertical garden and provides natural shade to the apartments. Up close in the eye of a honeybee, this image of a honeybee's eye is taken from a stop-motion animation made using a scanning electron microscope. I'm a photographer by profession, but have been fascinated by microscopy for 30 years, says Würzburg-based scientific photographer Stefan Diller. I thought it would be fascinating to make movies by stringing together images scanned by a microscope. So he invented Nano Flight, a technique whereby a moving subject is scanned from the same angle to give viewers the illusion of flying around it in 3D space. You get a deeper look into how the tiny parts on the specimen join together, says Diller. It's like flying in a small helicopter over a microscopic surface and looking down. The belly button's friendly bacteria. You're looking at 5 friendly bacterial families in the human navel, captured under a scanning electron microscope. In August, biologist Rob Dunn, an associate professor at North Carolina State University, released the biggest dataset of skin microbes to date, revealing that our belly buttons house about 2,400 types of microbes, 1,500 of which are new to science. We still don't understand why microbes on various people differ, says Dunn, even as we understand more about microbes as defenders of our skin. In 2011, Dunn's lab launched the Belly Button Biodiversity Project. What began as a way to get people excited about the microbiome became a serious endeavor when Dunn discovered the diversity in our navels. The August data dump included profiles of 273 participants, which the team posted on yourwildlife.org for microbe hunters to explore. We're still shining modest lights into a wilderness of species, Dunn says. There are just more lights. Tar sands are beautiful but deadly source of oil. These pretty patterns are tar sands in Alberta, Canada, origin of the Keystone Oil Pipeline system and target of heavyweight criticism from scientists. Tar sands are the dirtiest step into the world of unconventional fossil fuels, claims climate scientist and professor at Columbia University, James Hansen. A proposed extension means 830,000 barrels of this oil would flow daily across the Canada's border to Steel City, Nebraska, 1,897 kilometers away. Extracting the oil involves mining vast tracts of land, leaving reservoirs of toxic waste. Tar sands are much worse than conventional oil, because it requires a lot of extra energy to get them out of the ground and process them, says Hansen. ONA TransCanada spokesperson, Davis Sherrimata, Demers new data shows the oil sands are not much worse than conventional oil. There are a number of conventionally produced oils with a higher carbon intensity, including oil from countries such as Nigeria. The mystery of Mexico's crystal caves. These huge gypsum crystals in Mexico's Nika caves, some up to 12 meters long, have been growing for tens of thousands of years, but scientists have only now discovered what's inside them. We've recovered over 60 samples from tiny fluid pockets in the crystals, explains speleologist Penelope Boston, associate director of the National Cave and Karst Research Institute in New Mexico. Nothing that we've found is known to science. The crystal caves, which were discovered in 2000 by Mexican mining company Penelis, were opened to scientists in 2006 before being reclosed in 2010. When all the surrounding ores have been extracted, the water pumps will be switched off, and the caves will be reflooded.